Good morning. Today we will study Einstein photoelectric equation. So in our previous class we have studied what is electron emission, different types of electron emission like harmonic emission, field emission, secondary emission, and photoelectric emission. So this photoelectric emission is related to our topics. Okay, so we will study only photoelectric emission. So there we have also studied that in order to eject an electron from a metal surface we need a minimum energy. So that minimum energy is called threshold or work function. That minimum energy is called work function. And we have also studied that we need a certain frequency called threshold frequency to eject electron from metal surface. So today we will start Einstein photoelectric equation. So if you know what is threshold energy or threshold frequency work function, then it will be easy to understand this topic. So now let's start. According to Einstein, the energy of a photon is E equal to h mu. This yesterday also we have studied this one, right? So energy of a photon is given by E equal to h mu, where mu is frequency and h is Planck constant. So when a photon of energy h mu is absorbed by an electron, an amount of energy at least equal to work function is used up in liberating the electron free, and the difference h mu minus work functions becomes available to the electron as its maximum kinetic energy. So this means, so first photon of energy h mu is incident on the metal. So here see and the work function omega is what? H mu naught, nah? So this mu naught must be less than mu, okay? Because okay, I'll just explain you with number. Okay, suppose this metal, in order to eject electron from this metal, let's say frequency 2 is required. Okay, mu naught, nah? So this is called threshold frequency, nah? So we have to pass a light, nah, whose frequency must be greater than 2. Okay, if it is less than 2, then electron we cannot eject electron from this surface, nah? So it must be greater than 2. So suppose this metal, okay, metal work function it is 2, nah? So in this is the threshold frequency. Then so we have to give more than 2, nah? 3. Only then this electron can be ejected, right? Nah? So if then so this from this 3 2 na 2 will be used to eject the electron out, okay, and the remaining one will be left na. So this one will give the, see, this electron is moving, right? So what energy it will have? It will have kinetic energy na. So this one will contribute in the kinetic energy, okay. So now the incident photon has energy E equal to h mu, and we know that in order to eject electron work function, this much amount of energy is required. Huh? So from this much we have to minus this one, nah? So that we will get the remaining one. So the remaining one, that is h mu minus omega, or you can write h mu naught, is left for the kinetic energy of this ejected electron. So this must be equal to kinetic energy. Kinetic energy formula is half mv square, right? Maximum kinetic energy. So okay, now see, maximum half mv square maximum kinetic energy is equal to h mu minus h mu naught, or h mu minus this h mu naught is this one omega, right? Like that, like this also you can write. So kinetic energy is equal to h mu minus omega, nah? Or h mu equal to half mv square max plus, or this is minus, oh, this must be plus because it has change side, nah? Minus. Now so now this h mu take in one side, or you just move this omega in the other side, so it will become plus, nah? So it become plus. Now here this m is the mass of the electron, and this is the maximum velocity of the photoelectron. So this electron is called photoelectron, okay. Oh, it's written here, nah? Now the work function omega of the metal is a characteristic of the metal and does not depend on the incident radiation. It is sometimes also called the threshold energy of the metal. So as I have already told in the previous class also, that this work function does not depend on the what? Incident radiation. So and it is also called threshold energy. This work function is also called threshold energy, and energy formula is what? H mu, nah? If V naught or mu naught is the frequency corresponding to threshold energy of the metal, then omega equal to h mu naught, where mu naught is threshold frequency. That means this h mu naught is required to eject the electron, okay, and the remaining is used up for kinetic energy of the electron. Now if you put h mu naught, then in equation 1, nah? Or in equation 2, in place of omega just put h mu naught. So this equation is called Einstein photoelectric equation.